All right, so I do have a line now, and you said, hey, I thought we can't bisect a line. Well, somebody might want me to draw a perpendicular segment to this line. And since I have a point here, I want a perpendicular segment through that point. What I need to do is give myself a segment where this line is going to be the bisector. So I tightened my compass, and I'm going to lock in the space over here, and then I'm going to lock in the space here. So because I didn't move my bullseye at all, I've guaranteed that these two segments are the same. I can call this point A. I can call this point B, and I know that the distance, we'll call that M, from A to M is the same as the distance from M to B. Now that I found my midpoint, I claim that point as my midpoint, open my slider a little bit beyond the midpoint, draw an arc above, draw an arc below, transfer that same distance over from point B, and I'm going to draw an arc below, draw an arc above, and what I've done is I've used this point as that midpoint, that then this line is going to be the perpendicular bisector. So the same conversations about making a rhombus, because I have these distances that are all the same, are going to be true. And since I wasn't given a line segment, I made a line segment with that point as my midpoint. And there's my rhombus. All right, I can also do this from a point. I can draw a perpendicular segment from a point that's not on the line. And what I'm going to do for this one, same as I put my point here and declared my line segment, here I'm drawing the parameters. I'm going to give myself this line segment. Oh, and I'm out of risk here because of my spiral of my notebook. Let me go a little shorter. Hold on. We'll try to go a little shorter here. Where will my thing let me? There we go. All right, so we'll draw this line here and let this come around. Draw this line here. See if I can get around to it. Silly spirals. All right. So what I have here is this line here and this point here are going to give me my segment that I'm going to then perpendicularly bisect. So since I know that this distance up here, I can go ahead and swing my arc down because I need to find my lower point to draw. And then I have this point here, of course, is, there we go. And we'll bring this down and let this one connect down here. And then we have our perpendicular line through a point not on the line. So I can guarantee that this is bisected. I can guarantee that this is perpendicular for all the same reasons that all the other constructions also worked. All right, so we'll talk about construction number 5, and that is bisecting an angle. So when we bisect an angle, it's actually kind of cool. We want to create this line here that cuts this angle exactly in half. So anytime you're working with an angle, you're going to start off with what we like to call the working arc. And the working arc just gives us the point at where we're measuring from. When we talk about this angle, the space between these sides is very small here and very big here. So this working arc gives us a starting point. From that working arc, we're going to put our bullseye on this first intersection and then this second intersection. Now, I haven't changed my setting at all, but look at what I've created. I've created an intersection out that then now I can connect, and this is going to be my angle bisector. So let's talk about what we know is true for what we did. I know that this segment here is congruent to this segment there. I also know that this distance here is congruent to this distance here. And so we can talk about how that angle is bisected, because again we have a rhombus. And that rhombus guarantees that this angle, that this perpendicular line, is going to bisect that angle. All right, that is a bisected angle, proving that these angles here are bisected. Starts with step 1, drawing this working arc, and then step 2, drawing these arcs from these points of intersection out to the middle and then connecting, and you end up with that angle bisected. All right, our last construction we're going to talk about is drawing a parallel line. And this first step of this, just like we needed to start with a working arc for our angle, the first step for this one is I need to give myself a transversal. So once I give myself a transversal, now my job basically, if you think about it, is to give myself two congruent corresponding angles. So I'm going to copy this angle and put it up here. Now, somebody might say that they want a parallel line through a certain point or just any old parallel line. So I'll go ahead and I'll draw a point here and say I'd like my parallel line to go through that point. All right, let's start with our working arc. So I'm going to make this a little smaller to keep my construction a little tighter, but I'm going to go ahead and draw this working arc. And remember, anytime I work with an angle, that working arc just tells everybody, hey, this is the part of the arc I'm working with, so that I know where that angle is going to be. So this feels a little backwards because you're like, wait, we don't have the bottom part. I know, because that's the part we're waiting to see what's going to be parallel. So before, when we copied an angle, we measured up to know where to draw my line. Well, now we're going to be measuring down to know where to draw my parallel line. So what is the distance from this intersection to this other side of the angle? There it is. From this intersection here to this part of the angle, there it is. And then we can just connect those points, and we're guaranteed that these two lines are parallel because these corresponding angles are congruent. Parallel lines, if corresponding angles are congruent, then the lines are parallel. So again, step 1 was I drew this working arc. Actually, no, step 1 was I drew my transversal. Then I drew my working arc. Then I figured out my measurement and I translated that distance up, and then I was able to connect it for my parallel line. All right. So in your questions for SOLs, they're going to be asking you and showing you where different marks are on the diagram. And they're going to be asking you what it is that they're constructing. So when you see these marks above and below, you're like, oh, they're making a perpendicular bisector. When you see these marks here, oh, they're making a segment that needed to be created before they could bisect. When you see these marks out here, you know, oh, they're creating that endpoint for that rhombus so we can bisect this angle. When you see this working arc and these measurements, you know, oh, they're copying that angle. If you look at our other earlier constructions, here it's as simple as measuring the distance. Here it's as simple as measuring the distance between the mouth of the angle, creating that segment above and below. If they ask you to bisect a line, you need to make sure you remember that's not possible. If you're bisecting, it has to be of a segment. You can cut an angle in half, you can bisect an angle, you can bisect a line segment, but not a line. All right, so check out the sample problems that I've posted. Good luck.